Topographical.ca.
There's something almost magical about watching a 3D printer work. Layer by layer, an object comes into being from raw material. What was once science fiction is now, well, now. Today, you can buy a capable 3D printer for a few $100s. They're in schools, hospitals, workshops, and living rooms around the world. But this technology had to come from somewhere. Who invented 3D printing? Ask that question, and you'll get a simple answer. Charles Chuck Hull, the father of 3D printing. He invented stereolithography in 1983, patented it in 1984, and launched an industry. It's a clean story. A satisfying story. It's also incomplete. Let's start with the version you'll find in most history books. The year is 1983. Ronald Reagan is president, Return of the Jedi is breaking box office records, and in San Gabriel, California, an engineer named Chuck Hull is working late nights on a side project. Hull's day job was Vice President of Engineering at UVP Incorporated, a company that made ultraviolet lamps for industrial applications. One of their specialties? UV curable coatings. Shine ultraviolet light on certain liquid resins, and they harden into a solid surface. It was great for protecting furniture and tabletops. But Hull saw something else, a possibility. What if, instead of coating a flat surface, you could build something? What if you could shine that light in precise patterns, hardening the resin layer by layer, stacking those layers into a three-dimensional shape? What if you could print an object into existence? UVP gave Hull access to a small lab, nights, weekends, his own time, and on March 9th, 1983, he printed this. A small, black eyewash cup, roughly the size of a shot glass. Utterly unremarkable as an object. But as a proof of concept? Revolutionary. Hull called his wife that night and asked her to drive down to the lab. He had something to show her. The eyewash cup is still owned by the Hull family. His wife has mentioned she might donate it to the Smithsonian someday, and honestly, it belongs there. On August 8, 1984, Hull filed a patent for his invention. He needed a name, something technical, something that sounded like serious engineering. He'd been calling it 3D printing, but that felt too casual. So he coined a new term, stereolithography. From the Greek stereo, meaning solid, litho, meaning stone, and graphy, meaning writing. Solid writing. Writing objects into existence. The patent was granted in March 1986. Hull co-founded 3D Systems, and by 1987, they shipped the SLA-1, the first commercial 3D printer. Beta units went to General Motors, Pratt & Whitney, Kodak. The age of additive manufacturing had begun. It's a great story, a lone inventor tinkering in a lab, changing the world. But here's the thing about great stories. They're rarely the whole truth. Remember that date, August 8th, 1984, the day Chuck Hull filed his patent? Now let me tell you about July 16th, 1984, 3 weeks earlier. In France, three engineers were working on the exact same idea. Alain Méhauté, an electrochemist obsessed with fractal geometry. Olivier de Witte, a laser specialist at Silas, an industrial laser company. Jean-Claude André, a photochemistry researcher from CNRS, France's National Research Center. The project started, of all places, in a company cafeteria. Méhauté had a problem. He developed mathematical equations describing fractal geometries, infinitely complex shapes, where every small piece resembles the whole. But his colleagues didn't believe his math was correct. He wanted to prove them wrong. He wanted to build a fractal object. The problem? No manufacturing process on Earth could create something that complex. Over lunch, he complained about this to de Witte, and de Witte mentioned something interesting. Certain liquids could be solidified when hit with a laser beam. A light went on. They brought in André for his expertise in photochemistry. And here's where the story gets a little French. The three of them began working on the project without official approval. In French workplace slang, it's called en perruque, literally in a wig, an unauthorized side project. Their laser was even leaking and contaminating their makeshift laboratory. But they made it work. On July 16, 1984, they filed a patent for stereolithography, 3 weeks before Chuck Hall. And that patent was granted in January 1986, 2 months before Hall's. By every technical measure, the French team was first. So, why have you never heard of them? Their employers, French General Electric and Silas, looked at the patent and made a decision. They abandoned it. The official reason? Lack of business perspective. The real reason, according to Méhauté, cost cutting. The patent portfolio was expensive to maintain, and management couldn't see the point. Alain Méhauté eventually became a professor in Kazan, Russia. Olivier de Witte, in an ironic twist, briefly ran 3D Systems' French subsidiary. Jean-Claude André moved to the private sector and passed away just last year, in January 2025. When asked about it years later, Méhauté said, "I'm not bitter. I'm proud of the innovative work we undertook. Unfortunately, I am sad for our country because this is not the only example of French innovation that has been better harnessed by those overseas." But here's the thing, even the French team wasn't first. Let's go back further, 4 years before Hall, 3 years before the French, to a municipal research institute in Nagoya, Japan. In April 1980, a researcher named Hideo Kodama invented 2 different methods for fabricating 3-dimensional plastic models using light-hardening polymers. He called his device an XYZ plotter. In November 1981, he published his findings in academic journals, detailed papers describing layer-by-layer manufacturing using photopolymers, the exact principles that would later make Chuck Hall famous. The Guinness Book of World Records officially credits Kodama with the first written account of a working 3D printer. So, why isn't Hideo Kodama a household name? Because of this number, 60,000 yen. That was Kodama's annual research budget. In old money, that's roughly $545 for an entire year of research. His device wasn't highly evaluated by the laboratory. His boss showed no interest in the work. His patent application was abandoned because he couldn't afford to complete the examination process before the deadline. Think about that for a moment. The fundamental technology behind a multi-billion-dollar industry almost died because a researcher couldn't scrape together a few $100s in funding. In 1985, at age 35, Kodama gave up on 3D printing research entirely. He became a patent attorney instead. We've gone from 1984 to 1980. Let's keep going. 1967, the Summer of Love, the Six-Day War, the first Super Bowl, and in Denmark, a 27-year-old American graduate student is about to file the first 3D printing patent in history. His name was Wyn Kelly Swainson, and his background was English literature. Swainson wasn't an engineer, wasn't a chemist. He was a humanities student who asked himself a simple question. Why can we make 2D copies of paintings with photography, but we can't make 3D copies of sculptures? It seemed like there should be a way, so he taught himself. Swainson spent months in the British Library reading room, buried in patents and scientific journals, learning about photopolymers, plastics that harden when exposed to light, teaching himself enough physics and chemistry to turn his idea into something real. On July 12, 1967, he filed a patent for method of producing a 3D figure by holography. His concept was ambitious. Scan an object using laser interferometers. Feed that data into a computer. Have the computer direct two lasers to intersect inside a tank of photosensitive plastic, hardening it point by point into a perfect replica. It was visionary. It was brilliant. It was also about 20 years ahead of what technology could actually deliver. Swainson founded a company called Formographic Engine Co. He did research for DARPA. He filed more patents in 1971 and 1975. He never stopped trying. He never succeeded either. In 1988, the same year 3D Systems shipped its first commercial stereolithography machine, Wyn Kelly Swainson died. He was just 48 years old. An English literature student who saw the future, taught himself the science to describe it, but never got to see it arrive. So now we're back to 1967, 17 years before Chuck Hall. Can we go further? Of course we can. May 3rd, 1892. The United States Patent Office grants patent number 473901 to Joseph E. Blanther of Chicago. The subject? Manufacturing contour relief maps. Blanther's method worked like this. Take a series of wax plates, impress topographical contour lines onto each one, cut each plate along its contour line, then stack them together, one on top of the other, building up the terrain layer by layer. Listen to that process again. Cut material into shapes, stack those shapes to build a three-dimensional object, layer by layer. That's the fundamental concept of additive manufacturing, described in a patent filed during the presidency of Benjamin Harrison. But even 1892 isn't the beginning. Let's go all the way back. Paris, 1859. Charles Darwin publishes On the Origin of Species. Construction begins on the Suez Canal. And a French sculptor named François Willème files a patent that sounds like science fiction. Willème described himself as a painter, sculptor, photographer, and, in his own words, inventeur de la photosculpture, inventor of photosculpture. Here's how it worked. A subject stands on a circular platform in William's purpose-built studio. A massive rotunda with a glass dome flooding the space with light. Surrounding the platform, 24 cameras. One every 15 degrees, a complete circle. All 24 cameras fire simultaneously, capturing the subject's silhouette from every angle. Willème then takes each photograph and projects it onto a screen. He traces the silhouette with a device called a pantograph, a mechanical arm that copies the movement of one end to the other. As he traces the projected image, the other end of the pantograph guides a cutting tool through a block of wood. 24 silhouettes, 24 wood layers. Stack those layers together, and you have a three-dimensional sculpture of the subject. Artists would then smooth and finish the piece, adding detail and texture. Let's break down what Willème actually invented here. Multi-angle capture to record three-dimensional data. That's 3D scanning. Digital to physical translation through mechanical reproduction. That's effectively computer-aided manufacturing before computers. Layer-based construction of three-dimensional objects. That's additive manufacturing. In 1859, using cameras and pantographs instead of lasers and software, François Willème created a functional 3D scanning and printing system. And it worked. A traditional sculptured bust took months of an artist's time and cost 500 francs or more. Willème could produce equivalent results in under a week for about 50 francs. He opened studios in Paris, Venice, London, and Trieste. He photographed the Spanish royal family. His studio on the Boulevard de l'Étoile was the place to be seen in 1860s Paris. Of course, it didn't last. Financial troubles forced Willème to abandon his Paris studio in 1868. He returned to his hometown of Sedan and continued making photo sculptures on a smaller scale until his death in 1905. But for a few years in the 1860s, the future was already here. Over 160 years ago, 30 years after the invention of photography, 70 years before the invention of the computer, a sculptor in Paris figured out how to print three-dimensional objects. So far, we've been talking about one approach to 3D printing, using light to harden liquid resin, stereolithography, as Chuck Hall named it. But that's not the technology most of us use today. If you've got a 3D printer at home, odds are it works like this. Plastic filament feeds through a heated nozzle, melting into a thin stream that's deposited layer by layer. It's called FDM, Fused Deposition Modeling, or FFF, Fused Filament Fabrication. Same thing, different names. We'll get to why in a bit. First, let me tell you about a glue gun and a toy frog. 1988, Eden Prairie, Minnesota. An engineer named Scott Crump is frustrated. Crump had worked in manufacturing. He knew how long it took to go from a blueprint to prototype. Months, sometimes years. He had watched 2D plotters draw designs by moving a pen across paper, and kept thinking, what if you could do that with plastic? What if you could plot in 3 dimensions? One day, he decided to make a toy for his young daughter. He grabbed a hot glue gun, loaded it with a mixture of polyethylene and candle wax, and started building. Layer by layer, a toy frog. His daughter loved it, and Crump realized something. This process could be automated. He spent $10,000 on digital plotting equipment, nights and weekends in the garage with his wife Lisa, trying to turn a hot glue gun into a manufacturing revolution. Eventually, Lisa gave him an ultimatum. Stop this obsession, or turn it into a real business. In 1989, Scott Crump filed a patent for fused deposition modeling and co-founded Stratasys. His daughter, by the way, is officially credited as Stratasys' first end user. The toy frog is mentioned in the original patent. The early years were rough. Crump thought it needed $90,000 to reach profitability. It actually took around $30 million. In the first 3 years, Stratasys sold exactly 5 machines. But they kept going, and eventually FDM became the most widely used 3D printing technology in the world. Meanwhile, at the University of Texas at Austin, another story was unfolding. Carl Deckard was an undergraduate who decided to study mechanical engineering because, in his words, it was the closest thing to majoring in inventing. After visiting the Henry Ford Museum as a kid, he'd known what he wanted to be, an inventor. In 1984, while working a summer job at a machine shop, Deckard had an idea. What if you could use a laser to fuse powdered material together, building objects layer by layer? He approached a young assistant professor named Joe Beeman. Beeman saw potential, but he had a problem. The university administration wouldn't fund something this experimental, so he got creative with the truth. He told them that the laser was for cutting sheet metal. By 1987, Deckard had built the first working selective laser sintering machine. They called it Betsy. It ran on a Commodore 64 and used a salt shaker to spread the powder. The first objects it produced were just chunks of plastic, proof that the idea worked. The technology was licensed, commercialized through a company called DTM, and eventually acquired by 3D Systems, Chuck Hall's company. Deckard passed away in December 2019 at age 58, having held 27 patents and helped launch an entire branch of manufacturing. So by the mid-2000s, 3D printing existed. It worked, it was amazing, and almost nobody could afford it. Industrial machines cost hundreds of thousands of dollars. Even affordable options were tens of thousands. This was technology for big companies, not individuals. Adrian Boyer wanted to change that. Boyer was a senior lecturer in mechanical engineering at the University of Bath in England, and he had a radical idea. What if a 3D printer could print most of its own parts? A self-replicating machine. You build one printer, it helps you build another. That builds another. Exponential growth. And if you made the designs open source, free for anyone to use, modify, and improve, the technology could spread to everyone. He called the project RepRap, Replicating Rapid Prototyper. In 2005, Boyer launched a blog documenting the project. By 2006, they'd printed their first successful part. And on May 29, 2008, a RepRap machine produced another working RepRap machine. A parent making a child. When asked about his expectations for the project, Boyer said, "I had no idea if it was going to work or not. I gave it a 50-50 chance. If it failed, it failed. But if it succeeded, it would succeed quite well, because anything that copies itself grows exponentially." And then, in 2009, something else happened. The original FDM patent held by Stratasys expired. 20 years of protection, gone. The core technology behind fused deposition modeling was suddenly available to anyone. The RepRap community had been developing open source printers for years, but they'd been operating in legal gray areas. Now, the floodgates opened. MakerBot launched in 2009 with their Cupcake CNC. Ultimaker followed in 2011. Prusa Research, FlashForge, dozens, then thousands of companies piled in. Before the patent expired, FDM machines cost $14,000 or more. Within a few years, you could buy one for $300. In 2013, Stratasys, the company founded by Scott Crump, the inventor of FDM, acquired MakerBot for $403 million. Think about that. Stratasys paid $400 million for a company that existed because their own patent expired. And one more thing. You know how I keep switching between FDM and FFF? Fused deposition modeling and fused filament fabrication. Same technology, but FDM is trademarked. Stratasys filed that trademark in 1991 and still owns it today. Patents expire. Trademarks can last forever. So the open source community uses FFF instead. Technically different name, functionally identical process. So, who invented it? We started with a simple question. Who invented 3D printing? And the answer is complicated. If you mean the concept of capturing 3D data and using it to manufacture layer-based physical objects, François Willème, 1859. If you mean the specific technique of stacking cut layers to build shapes, Joseph Blanther's got a patent from 1892. If you mean using lasers and photopolymers controlled by computers, Wyn Swainson filed that patent in 1967. If you mean a working UV-cured 3D printed system documented in scientific literature, Hideo Kodama, 1981. If you mean a granted patent for stereolithography, the French team beat Hall by 2 months. If you mean actually building a business, shipping products, and proving the commercial viability of the technology, Chuck Hall, undeniably. If you mean the technology most of us actually use, Scott Crump's glue gun frog started something pretty big. And if you mean making it accessible to everyone, Adrian Boyer and the RepRap community changed everything. Ideas don't have single inventors. They have lineages. Genealogies of thought stretching back further than we usually bother to look. Willème couldn't have imagined stereolithography. Hall probably never heard of Willème. But they were both reaching for the same thing: turning information into objects, making the imaginary physical. The printer on your desk is the descendant of a French sculptor's photo studio, a Japanese researcher's shoestring budget, an English literature student's library obsession, and a father trying to make a toy for his daughter. 160 years of people asking the same question: what if we could just print it? And they're still asking. New materials, faster processes, bigger builds, metal printing, bioprinting. The technology keeps evolving. Because the best answer to who invented 3D printing might be, we're not done inventing it yet. Thank you for watching. If you like this kind of video with research and narration and animation, then please support us on Patreon or purchase something from our store. Being able to create content like this is entirely possible because of viewers like you. So thank you. And if you haven't already subscribed, go ahead and join the crew. Like, comment, and share. Thanks for watching. And until next time, keep making things work. One more thing. Remember Hideo Kodama, the Japanese researcher who abandoned 3D printing to become a patent attorney? I like to imagine him sitting in his office decades later, processing patent applications for 3D printing companies. The industry he helped create, built on the foundation he was never credited for, generating paperwork that crosses his desk every day. I don't know if that actually happened, but it's the kind of irony that writes itself. Anyway, bye-bye.